All right, guys, congratulations. If you have been working through this course, you are now to the last topic in Chapter 7, the trig unit. So congratulations, you have made it. I hope I make it simpler for you to understand these concepts, because I know these are very daunting concepts, but hopefully I'm kind of giving you guys a little bit of help here with simplifying it and being able to conquer them. Okay, so the last type that my students have loathed the most is this type. Okay? Whenever you see a fourth power minus a fourth power, you need to think difference of perfect squares. And that's something that a lot of kids forget about. When we factor, if we have two square terms that are being subtracted, we can do the difference of perfect squares, which is the square root of this guy. So we're going to say x and x. Square root of this guy, 5 and 5. 1 plus, 1 minus, doesn't matter which one's which, okay? So whenever you see a fourth power and a minus, or any squared term minus another squared term, you can do this. And this is cosine squared squared. So this is perfect squares, all right? So whenever you see those nasty little guys, let's think difference of perfect squares. This is difference of perfect squares right here. All right. This is the part we need to start with because that's definitely the grossest. So let's rewrite this as difference of perfect squares. So two sets of parentheses is where we start. The square root of cosine to the fourth. Well, what would be the square root of cosine to the fourth, or x to the fourth? Well, that would be x squared, correct? So same type of a thing, except for our x is a trig in this guy. So we're going to say cos squared t, cos squared t, and then we're going to take the square root of sine squared t, sine to the fourth t, so we get sine squared t, 1 plus, 1 minus, doesn't matter which one's which, over sine squared t. Okay, and we needed to get it to equal that shenanigans. Okay, well, sine squared, cosine squared, that's, a combination of that is a very popular Pythagorean identity. So looking at Pythagorean identities, which one is it? Right here, sine squared plus cosine squared. Doesn't matter the order because it's addition, right? So this is 1 based on the Pythagorean identity. So now we're left with just cosine squared t minus sine squared t over sine squared t. Okay. And then we can cancel these guys out. No, we cannot cancel those out because it's a plus or minus. Oh, so many kids do that. Don't be that kid. Don't do it. Don't do it. You can't because it's a binomial. You can't cancel out unless everything has it, okay? But just like we did before when we have fractions, we can separate it into two fractions, right? So let's go ahead and separate this into two fractions. So we can go cos squared t over sine squared t minus sine squared t over sine squared t. Sine squared t over sine squared t cancels out to be, whoops, that's just a minus sign, 1. What is cosine squared over sine squared? Well, cos over sine is cotangent, so this would be a cotangent squared t. So we get cosine squared t minus 1 equals cotan squared t minus 1, which is what we wanted. Bam, we are done. So see perfect square minus perfect square term, difference of perfect squares is where it's at.